Welcome to week one. Hi, everybody. This is Professor Stedman, and I will be leading this course or facilitating this course with you this semester. By this time, I hope that you have already looked at the overview of the class. Excuse my hoarseness. But yeah, if you haven't, make sure you do the overview of the class, which kind of puts everything in perspective. And today we're going to dive into foundations. Okay, so basically what we're going to be looking at starting out is what are the foundations of writing efficient code in C++ using algorithms and data structures. Now, the assumption here is that you already know C++, and basically we're looking at C++ and breaking it down into its various components, specifically related to algorithms and data structures. Being that that is the assumption, that may not necessarily be the case. Okay, so with that, we're going to be having some C++ primer. Many of our homework assignments are going to be in C++. So we're going to try to give everybody a chance to catch up, to be on the same level with C++ if you're behind. Okay, so with that, we're going to look at some of the foundations first for this week. And we're going to start off when talking about what are the four things that we're going to be concentrating on. Those four things we're going to be concentrating on for this class is going to be the concept of encapsulation, the concepts of a constructor, the matrix, and the process of recursion. Okay, those four things are what we're going to be looking at. Now, we won't be looking at that, going through that in itty-bitty detail, but we are looking at it from a point of we're giving a foundation that you're going to be expanding on when we talk about the homework assignment, when we talk about the quiz, when we talk about discussion questions if you're basically online, when we're talking about the project. Okay, so the project will be, I'll be mentioning that here in a second. So taking that in mind, if there's something that specifically you don't understand, contact me and we will go through it in detail. But what we're going to be showing here are kind of the highlights of the foundation. So for example, in week one, what are our learning outcomes? We want to explain the concept of encapsulation in object-oriented programming. We want to define and implement constructors in C++. Of course, we'll kind of go and say what are constructors. And we're going to represent and perform matrix operations in C++. So the concept of a constructor, the concept of encapsulation, the concept of a matrix are three of the basic data structures we're going to be talking about, data structures and algorithms. Yeah, we're going to be talking about. Okay, so at a glance, encapsulation. Encapsulation is the process of hiding data and protecting it through access control. The basic concept behind C++ is a class. And for those of you who have never taken anything about object-oriented programming, think of it simply as a file. And in that file, we have a certain number of fields. And what we allow in that file is to take some or all of those fields and protect them. Which says, you can't get to me. You can't get to this particular field unless you call me and ask for that field. Versus if I created a file and I said field 1, 2, and 3 are public, then I don't have to call you. All I have to do is access field 1, 2, and 3, okay? Because it is public and it's made known to everybody. So in this particular case, encapsulation is saying that it's a way of protecting information that might be contained in a file that we are calling a class. Okay, we'll get more into classes later. But that's encapsulation. For a constructor, special number function that basically initialize fields in its simplest form. And what that does is says that whenever you call me and ask for information, I'm going to make sure that certain fields meet certain criteria. I'm going to make sure that any amount fields are numeric and that it has the minimum value that I want it to have. I'm constructing the key fields in that particular class and saying, okay, whenever you access this, the information from this class, I'm going to make sure that all your fields are initialized to what they should be for you not to get to make a call to the class and then add in because you have, alphabetic information in a numeric field. Okay. So the constructor basically takes that opportunity to make sure that everything is legal and ready to go in a particular class. Then we have the context of a matrix. Okay, matrices, we're kind of repeating some of this information later on, but matrices are constructed of rows and columns. The most simplest, most straightforward example of that is going to be an Excel spreadsheet. Okay, an Excel spreadsheet has rows, has columns, and how I access that information is basically saying I want information in row 1, column 3. I want information in row 3, column 1. Okay, so basically knowing the rows and the columns, I basically can take that information and create a matrix. Okay, this particular case here is a 2D array. 2D is rows and columns. I can also later on in advance have 3D arrays where I have rows, columns, and depth. Okay. But in this particular case, since we're only talking about the foundation, we're talking about just a 2-dimensional array with rows and columns contained in it. We're also going to be kind of exploring in the homework assignments the concept of common matrix operations, where we're taking two matrices and we're adding them together. We're taking two matrices and we're multiplying them. We're taking two matrices and we're doing a transpose. And here we're identifying the matrix. So here are the operations that we're going, the identity matrix. An identity matrix, and you'll see later, the identity matrix says, okay, if I multiply the identity matrix by any matrix, it gives itself. It's like a 1. 1 times anything is the anything. Okay, so that's what an identity matrix is. Okay, matrices are widely used in graphics, simulations, machine learning. Okay. You'll see a lot of matrices as we move along. You will see matrices in your project that we will be talking about. And just as we don't get it in what I want to say is that make sure you're in class. Okay. Make sure you're in class on Thursday. Okay. Because we'll be having a lot of information about setting that foundation of what you need in order to write C++ programs and information about your project. So need for you to be there, be at class on Thursday. Okay, vocabulary definitions. This is more formal encapsulations, and taking this from my glasses so I can see. The bundling of data and methods that operate on data in a single unit, and that's being a class, and restricting data access to some of the object's components. Constructor, a special number function that is automatically called when an object is created. So when I create an object is an instance of a class. Okay. When I take that and I create one, I'm going to automatically initialize the fields that need to be initialized. And then a rectangular array, okay, rows and columns. I can have more rows than I have columns. I can have more columns than I have rows. That's what the concept of rectangular says. I'm going to either be rectangular horizontally or rectangular vertically. If my number of rows and my number of columns are the same, I have a square. Okay. So that's part of the vocabulary definitions. Okay, why does this matter? Okay, let's see if I can blow this up a little bit. There we go. Why does this matter? Okay, to protect data and prevent unauthorized access. The reason we encapsulate information and we put that information in class is for protection. There are certain fields that we may not want everybody to see at their whim. We want to control who has access to that information, and encapsulation allows for us to do that. Ensure proper object initiation and consistency. That's basically what we said. Make sure all the fields that should be initialized. Also, the way you can think about it is if you buy a product, okay, and say it was an app, okay, on it, and the app, when you access that app and it's given to you, you buy it, there are default values, okay. So the default value says in order for this particular app to work, these particular fields had to be initialized with the default values. Now you can go in there and change them. Okay, change those values. You can say, oh, okay, I want to be able to override the date. I want to be able to override the name. But there could be standard information that we put in those fields, okay, in order to make sure that it can run when it comes out of the box. Okay, so with that, that's what we're talking about with a destructor. Okay. So that's here to show proper object oriented, right? Modular, reusable, and maintainable code. One of the things I want to kind of highlight is with that particular statement, what it's saying is we're not writing code just to be writing code. Okay. We're not writing C++ just to be writing C++. We want to write C++ that's efficient, C++ that is modularized, and C++ that is correct. Okay. So with that, we're going to be concentrating when we talk about algorithms and talk about data structures, kind of which ones are best. When I put in a data structure, should I put in a vector or should I put in a regular queue? Okay. So we're going to be talking about the good and the bad of what we select as far as data structures and algorithms. Okay, so then we have model real world problems using matrices. You'll have that opportunity in your project. And essential for algorithms in science, AI, engineering. AI is big now, okay, which I'm sure that you guys are going to be using at some point or another in this class. Okay, you cannot get away with using or AI to do what it can do without having these components. Okay, as far as the algorithms we're going to talk about, as far as the data structures that we'll be using, it must have those particular pieces. So the things we were mentioning here is the foundation. Again, is simply the stepping stones that we need to put in place for all these advanced concepts that we're working with in the real world. Okay. Oh, didn't mean to do that. Okay, sorry about that. Take you for a little while ride there. Okay, so examples. Examples, encapsulation. An example given here is a bank account. Okay, and I think there's the example down here also covers that. But in the bank accounts, you don't want everybody to get to your balance. Okay, so what we do is we encapsulate the balance into an account class. So the only way I can get to that balance is to have authorizations to be able to call the class. So once I call the class, then I can get information that might be contained in the class. That's encapsulation, blocking that information that we don't want others to get. Here, a new product comes out with default values. I was saying that, this is basically when we call that particular class, it's going to be a constructor that says, I want the time to be 12 o'clock. I want the amount to be 20. I want this array to be a 3x3. Okay, all that information that should be standard in order for this particular object to work, okay, are established in a constructor. And then matrix, spreadsheet, can't get any simpler. A Microsoft Excel spreadsheet is a classic example of a matrix. So in looking at some of the simple C++ code, you'll be writing your own here in a little bit. Let's see if I can get that. There we go. So in looking at this particular case, as far as the examples, here's an example of encapsulation. Again, where we're taking into account, we're saying the balance is private. What's balance is private says not everybody can get to it unless they call the account class. Okay. Once the account class is called, okay, here we define the balance. We take the amount that you're passing over, we're adding that to the balance, and then we're passing the balance back. That is basically, that's the only way I can get to the balance is through this encapsulation process. Here's an instructor where I'm initializing in this particular point. Okay, so I have to have an X value and a Y value, okay, to create that point. So I call this particular module, and it will initialize the X value and Y value so that the point exists, okay, when I need to identify a point. Same thing for here for the matrix. This mesh is basically establishing the number of rows and number of columns that are in the matrix here. So here we've created the matrix here, mat, rows, columns, and we're initializing. We're initializing row. Notice the 0, 0, 0, 0, 1. The 0 basically says where's the matrix going to start. Okay, the matrix starts at 0 and goes up to n minus 1. So here I'm actually looking at row 0, column, I'm looking at row 1, column 1, row 1, column 2, row 1, column 3. Here I'm looking at row 2, column 1. Column 2, excuse me, column 2. Okay, so here the 0 and the 1s are 1 off. Okay, so just an example of how this particular C++ code is utilizing, okay, the examples for encapsulation, constructor, and a matrix. If I was to walk through the code, in this particular case, I'm basically creating a rectangle. So I'm going to send, I have a private for the width and the length. And so here I'm creating a rectangle of W and H, the width and the height. We're setting the width equal W. We're setting H to be the height. And that basic information that we passed over here with the rectangle, we passed over, this is public. And then with that information, I'm establishing the criteria for the rectangle. Kind of an explanation. One of the things that I am going to be pushing when you write your programs is I'm going to be pushing for you to identify in each line, what is it doing? Okay, so when you have a problem that you're doing, say, okay, I'm going to use AI. Okay, I'm just going to run this through the AI, give this to me. AI gives it to you, gives you the code, gives you line 1 through 20. You think you're good to go. No, I want to know exactly what each line is doing. That's going to be the standard practice in this class. If you do not turn over what the exact line by line it is doing, you will get half credit. Okay, let's make sure we understand that. You will not get full credit for a C++ program unless you explain in detail, line by line, what each line is doing. Okay? Okay, just want to kind of throw that out there. We'll kind of emphasize it again when we send homework and everything. Line by line. Each line should have a definition as to what that particular line is doing. Okay, so common mistakes that are made by students, making data members public. Okay, if you make a class public, then everything in the class is public. Okay, so this is saying that, okay, now, be careful that you want to make your class private, okay, or maybe certain fields public, but not the whole class. They're making it public because, again, that basically says here, it defeats the purpose of encapsulation. Okay, if you can get to any field because you made the whole class public. Here, forgetting constructors, not initializing fields in the object or the class. May be left uninitialized. That causes problem when you call it a class because some field you thought had some information in it. It doesn't. Okay. And then we've got a matrix index errors. We said you should start at 0. You thought 0, which is really row 1, was row 0, which there is no row 0. Okay. Or you looked at row 2 and you thought you were in row 2, but based on the way the matrix works, you're really in row 1. Okay, so here, accepting values outside indices when I thought I had a 2 by 2 array. So I accessed a row 3 that's outside the bounds. Can't work, can't do it. Okay, so this is the overview of week 1, are the concepts that we want to concentrate on now. You do have a simple homework problem in C++ to kind of touches some of these things that we talked about. The key thing in order to the quiz and the homework, answer these questions. What is the main purpose of encapsulation? When is the constructor called? Why is the constructor important? How is matrix stored in a C++ program? What are the dimensions of a matrix with 3 rows and 4 columns? Look that information up. These are just base questions to kind of guide you into what you're going to need for the quiz and for the homework and identifying those fields. Okay, so that's 3 of the things that we wanted to talk about. Okay. I have one screen that's touch and one that's not. Okay. Okay, so we wanted to talk about the encapsulation, the constructor, and the matrix. Okay, the other thing we wanted to talk about, okay, is recursion. Okay, the concepts of recursion. Okay, so what we wanted to do with this particular case, with recursion, we wanted to kind of highlight this functionality, which is in our algorithm. And hopefully I can enough so you can read it. Okay, so here we're talking. We want you to be able to know, explain what recursion is. We want you to be able to define a recursive algorithm and identify the parts. We want to identify and describe the base case, understand and analyze different cases in recursion, implement recursive solutions in C++, and describe C++ sections and objects. Okay, so this is the other piece, encapsulation, constructors, matrix, and now we're going to be talking about recursion. Okay, the basic concept of recursion is when a function calls itself to solve a problem. Okay, that the way it solves it is here. I have a problem. I'm going to break it into pieces. I'm going to take one of those little pieces. I'm going to go ahead and I'm going to solve the smallest component, and then I'm going to build a solution. Okay. Each time I call a piece, that piece is going to be one of the components that I use in answering the problem. Okay. So if you look at this, recursion is a powerful problem-solving technique, and in many cases, computer science beyond. You will have part of your assignment. What's a fractal? As far as a file system, if you think about the way a file system is constructed, it's basically broken into pieces, and you go down each level until you get to the app or to the file that you want. Here, game trees. We're going to talk about the concept of trees. So game trees works with recursion. Nested structures, like the Russian dolls. Each doll is contained within another doll. So one's contained in here, which is contained in here. Okay. So you basically have to break the doll into pieces in order to get all the components. Divide and conquer. One of the classic divide and conquers is the binary search. That's probably one of the homework assignments, I believe. But in binary search, you basically cut your problem in half, and then you either take the top half or the bottom half, and whichever you take, you cut it in half. And so basically you're cutting your file into pieces each time you execute it. And that's the concept that kind of describes recursion. Okay, everyday examples, stair steps, you take one step at a time in order to get from the bottom to the top. Each time you step, you're using the same process in order to step up the ladder. Mirrors facing each other. You've been in that situation. If you've been in a barbershop, for example, and there was mirrors on both sides, you hear that perpetual method that each that you're going into infinity, because each picture is taking a slight view of what the other picture is. And so that's mirrors facing each other. That's kind of a weird concept of recursion. And then we said about the Russian dolls, where the smallest doll is contained in the next doll, which is contained in the next doll. And so in order to get everything, you're just basically breaking these into pieces. Countdown, if you're doing a countdown, you're going from n minus 1, n minus 2, that's using a recursive function, where each time I'm going through the same process, but I'm using a smaller subset of what I'm basically having to count down. Computer science examples, tree transversals, factorial calculations, Tower of Hanoi, binary search, linked list. These are some of the things that you'll be looking up for your homework assignment, as far as what they are and how they're related to recursion. Here for C++ example, here's the factorial. And in fact, I think one of your homeworks is the factorial, so this is basically a guideline for that. Here I have an n, so if I wanted, 5 factorial, here, this is, you'll find out that this is my base class, but I return 1 if n is 0. Otherwise, I take n and I multiply times the factorial of n minus 1. So if I had 5, I had 5, and I'm going to multiply it by the factorial of 5, of 5 minus 1, which is 4. And then I'll break that down and give me the factorial of 3, and give me the factorial of 2, and give me the factorial of 1. Then with those particular pieces, I'm multiplying 5 times 4 times 3 times 2 times 1, and I get my factorial. Breaking things into pieces, concept of recursion. Very important concept that we're going to be using, and you need to kind of know the foundation of when you want to use recursion and when you don't. So here, again, using factorial, here's the factorial process. I call for factorial 4, then 3, then 2, then 1. When I get to 0, I return 1. That is my base class. When I hit a factorial 0, that tells me I don't need to do anymore. I don't need to make any more calls. So the code walkthrough, basically the same thing. This kind of highlights what you're going through. The base class stops the recursion. Common student mistakes, missing the base class. You have to have that base class. And when do I stop? Something has to tell me that when I reach this point, then I don't have to do any more recursion. It's done. I'm at the end. So not putting in a recursion base class or defining a recursion base class for that. Wrong base class. You put in a base class, but it's not going to stop anything. So you have to be careful that you're using a base class that says, then when you reach this point, this particular piece, you don't have to do any more recursive calls. And not reducing problem. If the problem doesn't get smaller with recursion, then it will never end. If I'm always not in my next section, if I'm not getting a smaller piece of the overall problem, I started out with a big piece A, and I did a recursion, I still got piece A, and I did a recursion, I still got piece A. No, it's not recursion. I got to get A, something smaller than A minus 1, smaller than A minus 2. That is the concept of recursion, and things that we need to make sure that we highlight. From a knowledge check point of view, what is recursion? What is the purpose of the base class? What must each recursive call make the problem? Why must each recursive make the problem smaller? Why does the factorial function return what does a factorial function return when it's 0? And then what is an object in C++? All of these we're going to be kind of pounding on as far as for your homework assignment, quiz, discussion problems for those who are online, and your project. This kind of highlight, I'll mention that each your project is basically going to be, the pieces of it are going to basically be assigned each week. Each week you will have something to do on your project that relates to the previous week's discussions. So this week we talked about recursion, encapsulation, matrices, and 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 the others is what we're talking about here is that the homework, the assignment for the project, okay, the assignment for the project for week one of the project won't be given until week two. Okay, so week two, we're going to give you an opportunity to go through the foundations, go through the homework, go through the quiz, understand what is involved. Okay, when we're talking about that's already did. Hold on one second. Yeah. So here, since we're talking about an encapsulation constructor and matrix, this is in week one. The whole the project, okay, for you won't be touching this information until week two. Wanted to give you the opportunity to learn all the concepts, okay, from week one, and then applying those concepts to your project. So we're going to be staggering. Week one, you will have nothing on the project. Week two, you'll be looking at the information from week one. Week three, you're going to be looking at the information from week two. Okay, so it's going to be a stagger so that it's kind of very important that you don't miss anything. Now, I'm just going to lay it out there. Don't think says, "Oh, well, I'm good. I can do week one and then jump to not do anything for you until I get to week four." Not going to work. Okay. If you fall behind, you're hurting yourself. Don't fall behind. Do each assignment each week as it's designated because each one is a foundation on the other. What we have in week one is going to be foundational to week two, which is going to be foundational to week three. Okay. So just keep that in mind. That's the way things are going to work. We'll go more of this in class. Also, if you have not already done so, you should make sure that you can get the C++, the editor, which one we're using. And in this particular case, we're using, if you should have got it for Visual Studio Code. Okay, so you should have gone through the process of setting that up. I did have the instructions in week one. Make sure you've reviewed those and that you can get access to create a C++ program based on that information. If you have any issues, let me know and we'll work through make sure that you can set up. Okay, so we're going to close it out there. Again, kind of an introduction on week one. What we're going to be concentrating on, we'll kind of be expounding on this in our assignments on Thursday when we're doing face-to-face. We'll go in maybe to a little bit more detail, but specifically more of actually writing C++ programs that kind of emphasize the information that we have here. So there we go for week one. Have a good one. And again, I know there's sometimes some people say, "Well, I don't need to look at the video." You need to look at the video. Okay. Just mark that down. Okay, everyone. Have a good one, and I will see you on Thursday. Appreciate it. Bye.